Hi, my name is Dylan Horgan, and this is my presentation on other input methods for interacting with technology. Uh, I'm defining other input methods as distinct from keyboard input, indirect pointing devices, or direct touch input. So first off, I'm going to discuss speech recognition technology. This is basically technology that identifies and interprets spoken words. Examples of this in the real world would be smartphones, such as iPhones have Siri as a virtual assistant that can do things based on user prompts verbally. Smart speakers, I have an Amazon Echo myself. You can raise or lower the volume, for example, using your voice when music is playing. And also smart home appliances, such as security and lights. You can activate or deactivate based on verbal commands. So the pros of this technology is that it's simple. People understand how you can give verbal directives to affect something. Um, it's more accessible for some people with disabilities, such as people who you know might have poor, motor skills. For example, they could use their voice to, uh, provide input. Uh, it's convenient if a user's hands are full. This is, a big benefit of Siri in particular. And also, talking is generally faster than typing if you're trying to accomplish a task that requires typing. So the cons of speech recognition is that it has a high error rate. I know anyone who's tried to send a text using iPhone's speech recognition software knows that it's can be ineffective. It has low throughput, which means even though it is faster than typing, when you think of all the things you can do with a computer, for example, it's actually a relatively slow way of conveying information if you had to give verbal commands for everything. And additionally, speech recognition software can be difficult to use in noisy environments or impractical to use in quiet environments. So it's not as versatile in terms of the locations you can use it in as more traditional input methods. Other kinds of audio uh, um, input methods would be, for example, Shazam. Users will play music at this application, and it can tell users what the song is that's playing. Additionally, I use this app myself, Guitar Tuna. I'm sure most people who play guitar probably recognize it. You can play guitar while the app is running, and it will tell you the exact note that's being played, if it's flat or sharp, and you could adjust your guitar accordingly so you can tune your guitar using this application. So the next form of input method is gesture recognition. This is basically technology that you interact with through hand movements or facial expressions. So real life applications of this form of input method would be, for example, video games. Many people probably remember Microsoft Kinect. Uh, Also, I was reading about this in medical procedures. Sometimes surgeons will have a monitor present, for example, with X-rays, and they'll interact with this monitor using hand gestures. It's good because it's a sterile form of interacting with technology. It's for in that um, specific task, it would work better than a touchscreen. And also smart mirrors. People don't want to touch their mirror all the time; it fogs it up. So smart mirrors use gesture recognition technology as their primary form of input. So the pros of this input method is that it's intuitive. Um, Most people know how to, manipulate objects with their hands, so it comes quickly to users. It removes the need for supplementary devices. Sometimes controllers and remotes can be expensive. Um, and it's a versatile way of conveying information. For example, um, you know, compared to a mouse, you can just do a much larger variety of things with your hands compared to a mouse, which other than the certain directional movements and a couple buttons, it can't convey all the various things that your hands can. The problems with this input method is that it's inaccurate. I'm sure most people who remember playing Microsoft Kinect is not as precise as a traditional controller. It can be inaccessible for some people with disabilities, for people who maybe struggle with some form of paralysis. The technology would not read their input correctly. Uh, Additionally, it can be fatiguing for users. It is not as comfortable to use as a traditional mouse, for example, and it requires a relatively high processing power. Next, eye tracking. Eye tracking is technology that decodes eye movements and translates them into directives. So, real life applications of this input method are, it seems to be, based on my reading, mostly research contexts. For example, in education research, they'll use eye tracking technology to see if students are responding well to different teaching methods. They want to maximize the attention of students. So eye tracking technology will be used to measure that. Um, in medical diagnosis, eye tracking technology has been used to diagnose patients with ADHD or autism. And additionally, in marketing research, similar to education research, input tracking technology has been used to basically see how the typical customer would respond to certain stimuli in terms of what draws their attention, what doesn't. So the pros of this input method is that it increases computing and resource efficiency. It's valuable for assessing human conditions and behavior, as I was describing before, and it's non-invasive compared to old school ways of, for example, at an eye doctor, of examining your eyes. It is relatively non-invasive. So the cons of eye tracking technology is that it's expensive. Contact lenses or long eyelashes have been known to cause issues. And I think this is the big thing compared to, for example, hand gestures. Involuntary eye movements make precise responses. Um, it just makes things inconsistent and difficult to control. And eye tracking technology tends to require calibration or long calibration periods, which can be frustrating for users. Next, iris and fingerprint recognition. So, iris recognition is an automated method of identification. Basically, identifies people based on their iris in their eye. Fingerprint recognition can identify people based on their fingerprints. So, real life applications for this technology, it's used in security, as you can imagine. It's used for verifying voter identities. It also can be used for fraud protection. So the pros of this input method is that it's highly accurate. It's easy to use. It removes the need for passwords. In security, this is useful because people can forget their passwords, or passwords can become insecure if they remain the same for too long. So the cons of the software for iris recognition software, it can be thrown off by glares or reflections. For fingerprint recognition, it's not usable by some people. So for people who don't have fingerprints, or maybe they don't have control over their limbs, they would not be able to use this technology. And both of them have issues where they're expensive, and for some situations, it's just not practical. Like if it's in an area where system failure occurs often, you know, it can block access if you install iris or fingerprint recognition software. So a different form of security would be necessary in that context. And there's also handwriting recognition technology. So this is recognizing and interpreting handwritten data into machine readable output. Real life applications for this input method are digitizing handwritten documents. So people have used this to, for old documents that existed before typing. It's a good way of feeding large amounts of data into storage. The software can, read human handwriting and interpret that into text. Also for optical character recognition for the blind, so people can wear. I think this is more experimental, but people can, if they have problems with vision, they can read. They can wear glasses that will convey information to them, and also this type of input method pops up in note-taking applications. So the pros of this input method, it enables automated processing of old pre-typing information. It's accessible for people who don't type, and user input is identifiable as uniquely their own. So compared to, um, typed out messages, you could convey, you could, identify a certain person definitely made this input, based on their handwriting, which is not possible with a normal font. So the cons of this software or this input method is that it's generally not super accurate at the moment. It's a less efficient way of communicating info, both in terms of time. Obviously, handwriting takes a while compared to typing, but also it, you know, takes a lot of space for storage. Basically, all this stuff needs to be stored as images, um, and these images need to be high quality. So, other forms of input methods that exist out there. There's bio-tracking, for example, heart monitor applications. There's temperature sensors, which is self-explanatory. It's basically electronic thermometers. I was thinking about this off the top of my head. There's accelerometers in an iPhone, which basically acts as a level. It's made to basically you could balance your phone in a certain way, and it'll tell you if something's level or not. And also, I think this is totally experimental at the moment. I don't think it's ready yet, but some people have been working on um, uh, an iPhone app which could identify smells for you, identify bad breath, for example. I don't think it ever panned out, but it's in the works. So yes, that is my presentation on input methods, other than the traditional kinds.